This
Right? Services
conference will
go.
now be recorded.
Rohit?
Yes, can you hear me? Yeah, tell me.
Yeah, yeah. Still, we have other board services, right? Board service is there, Archway is there, and test plans also is there, right? We discuss so
Yeah,
far. We discuss
so
about pipeline.
exactly. So we so far discussed only pipeline and repos. Okay, we are going to discuss about Azure Wiki, boards, okay, and artifacts. Not much into the test because artifacts and all those things, right? They are still good, but right now what I'm telling you is that whenever we are using Azure DevOps, we are primarily using these four services: Azure Pipeline, Azure, Azure Boards, Azure Repos, and Azure Wiki. Artifacts, yes, sometimes I'm saying that's what I'm saying. Test is something which you will be really integrating, and test is altogether a different topic. There are a lot of things actually which are involved. So I'll give you a high level overview about that particular things, but the other pieces we will really get into. But before I want you to spend more time onto this repos and the pipeline because that's most important. Artifact, this boards and your wiki is something which people don't really use, at least in a Azure world, in laptop, if I talk about, right. And if you're already aware about the Jira, definitely that will be exactly the same thing. But yes, don't worry, I will actually take that one when we will start as a project. Okay, perfect. Let's get started. So let me share my screen. Okay, so what we have done yesterday, right? So we have seen that in case, and that is what I'm going to really explain you again when we discuss exactly the same thing. Let me start recording. Yeah, recording is already started. Okay, so as we have seen, right, there are a couple of things which we have done so far. Is first of all, we have created as a repository, and then we created a pipeline. As a first step, we seen how we can really build up and deploy the kind of like, or build, first of all, as it really started, how to build and push a Docker image using a pipeline. That's where we really started. So we have seen a basic task which can connect to your ACR. So before that, you need to really create a ACR because these services you need to create. And then once you create these services, you can then connect that with your Azure pipeline using service connection, right? This is what we generally call it as a service connection. And using the service connection, you can deploy you can push your Docker image, you can build that Docker image, and then you can push that Docker image to your ACR, right? That's what the first thing which we have tried. The second thing is, when we are done with this one, the second step, definitely once you are having a image in your ACR, we want to deploy that image back onto the app services. So first I've showed you the manual way, and then we get into a something, another piece or another task, which is the deploy task. Now what this deploy task is doing, it is deploying the application service, okay. And then when it is deploying, you need to really have this web application already available, right? These two services needs to be already available. So you can just push this or maybe execute this particular task. You mention all the web application details, and once you provide that one, it will go ahead and push or deploy this image whichever is available in the ACR into this web application. Okay, now before that, we also need to make sure that we are putting up the proper configuration. So we have added the app configuration details in our pipeline itself, which is going and updating my credentials, ACR credentials, in my web application. Correct, that's what something which we have seen. Now as a implementation, definitely these are the two things which we have done, and I'm sure you might have done that, like repeated that as we have done. And I have showed you multiple images, right, building up, and you can just deploy it. Because the beauty of Docker image is that it doesn't matter that what kind of a configuration or what kind of a program you have in the Docker image, right? It can be Java, it can be .NET, it can be Python, anything whatever you have. Once the image is created, this web application will just run that image, as simple as that. Okay, it doesn't bother about whether I'm running any which technology. It doesn't really matter about that one. It only matters when you are having a coding and all those things. Perfect. So we have seen that one. Now the the part is okay, we are good, we are having a build and deploy pipeline, everything is looking good, but the challenge here is that I don't have these services automatically created, or I still have a manual way of creating these services. Correct. So what we seen, that how can we really automate this particular process? So before even running my build and deploy, I should have these kind of a solution, or these services which are really available. So for that, what we can do is we can add one more task, which is for IaC deployment. What is IaC? IaC is infrastructure as a code, right? That's what refer. So when you talk about infrastructure as a code, that means we are writing a code, and that code is going and deploying or provisioning the services in my Azure environment. Okay. Now when we are going to do it, definitely we have one solution for that, and we have seen that solution is a Azure CLI. Now, initially, I showed you a few commands of Azure CLI. With this one, we can really go granular, and we can see that how, first of all, we can create a ACR, how we can really create a web application, how can we attach our username and password, which is in the ACR, to my web application, all using Azure CLI. Okay, that's something which we have really seen yesterday. Now when we are executing this Azure CLI, we can use a task which is already provided and a part of my pipeline, and I can write all that Azure CLIs, everything, like it can go, it can configure, and it will make my infrastructure ready before even I want to deploy anything. Perfect, because this is the mandatory thing. If my infrastructure is not ready, then I cannot push any image because my ACR is not available. I cannot deploy anything because my web application is not available. So this is how the separation happens when you are going to run a pipeline. And as a DevOps engineer, it's your job is to ensure that these all things are ready before even any developer is trying to push the code in their Azure repository. So how can we really do that? So the best option is to create, and first of all, divide this into a multi pipelines, or not just one single pipeline, but multi pipeline, because in a production environment, you will hardly see everything going in one step. It's not happen. Okay, in a production environment, it is actually separated or break it down into the multiple stages. So you have one stage or one pipeline only for IaC, you have one pipeline only for build, okay, and you have one pipeline only for deployment. Now why we have this pipeline? Because we are now separating out the roles, actually, whatever people are or whatever the developers are really doing. Because here, what I do here, that I know I have three repositories which I want to create. I want to create a IaC repository, I want to create a build repository, and I want to create a deploy repository. Now IaC and deploy, these two repositories, only DevOps person should be having access. Build, yes. Why? Because build, it requires the code, so we can provide the access, and there is only one file or some kind of like a pipeline which we are going to create. That pipeline will ensure that it has the Docker file. Along with that, it can also have some predefined test, whatever yesterday we have discussed, right? That DevSecOps practices, like you are doing the code scanning, you are doing some vulnerability scanning, you are doing the image scanning. All that process will be part of your this build pipeline. And then you will be having a deploy pipeline. Now why we are actually separating deploy pipeline? Because there is one tool which we are going to use, that is Argo CD. And now let's come into this section. Now what we are going to do, we are going to create a separate pipeline or repository, and then in that repository we are going to just have a IaC, infrastructure as a code. Along with that infrastructure as a code, we are going to have, in this infrastructure as a code, we are going to have a CLI, Azure CLI, along with Terraform, for provisioning my infrastructure. Because right now you might be thinking that okay, I have just two instances, but imagine you want to create hundreds of instances. You want to create everything whatever you have in one project. Say like in one project you have 10 applications, and for every application you want to create some different infrastructure. So do you want to create 10 different IaC? No, definitely not. You will be creating one Git repository, and that one Git repository will become a source for all that infrastructure. I don't want to have my infrastructure code as separate places. I don't want that because it will be become more so complicated for me to really keep a track of that, which infrastructure code is in which particular Git repository. I'll be go mad as a DevOps engineer. So I want one repository or limited repositories per project, so I can at least understand that in this project, say like I have created 100 virtual machines. Okay, fine. All those 100 virtual machines are available in this particular IaC. In case if I want to make any change to that virtual machine, I will go and only update that one particular piece. Now, as we know, right, when you are creating hundreds of resources in a Azure, in a for Terraform, right, what is going to happen is it will only touch that particular piece which is only updated or deleted or added. That's it. So it is not going to make any change to the existing thing which it already created. So say like it created the ACR. It will not going to touch the ACR. It will say, okay, I've created this ACR. The ACR is really looking good and it is looking as expected, whatever the configuration I have really written in by it. So what will happen? My state, or when we talk about this particular thing information, my Terraform will become a source of truth for my, okay, source of truth for my infrastructure. So whatever is written in my code, okay, whatever is written in my code, I'm saying that, okay, in this my in my code I want to serially have the one virtual machine. So it will say okay, and then whenever I run the Terraform, it will ensure that I'm going to create only one virtual machine or one ACR. That's it. Tomorrow I say no, create another ACR. Okay, fine, no problem, it will add up this one. If I delete this ACR from my code, if I delete, I'm remembering, if I delete the code from my thing, then it will say okay, delete it from the infrastructure also. So that means this code will become a truth, and that's where it called it as infrastructure as a code. Why? Because everything is now driven by this code, not by this Azure. And tomorrow, in case if someone delete this particular resource, say like someone goes and delete this resource ACR, it delete the resource, it will automatically created by Terraform with all the configuration whatever I have written in the source here. So you are not losing anything here. Perfect. So we are going to create a separate repository. Now, once we create a separate repository, definitely we are going to create, and that's where we are saying DevOps person will have access to this repository. No developer will have access to this repository. Then we are going to create another repository that is only for build. In this build, we are going to give access to DevOps as well as developer, because DevOps will require to create a Docker file or something like that. Or you can really give them based on your requirement. They maybe you will not have access as a DevOps engineer. Say like you don't have access. You can say okay, use this Azure pipeline YAML file and maybe use this particular thing and let me know if this is working. If there is a problem, I can fix it. But generally that won't happen. Generally you will definitely have access, so this particular person will have access to this repository also, but again a limited access only for providing the Azure file, Docker file and Azure pipeline, so just for that creation. But this guy will continuously having access and he will be continuously doing, and then he will be doing build, code scan, image scan, everything is happening here. And then once it is everything is there, then it is going to deploy into the ACR which created by my earlier pipeline, which is using Terraform. Now, once I'm done with this one, right, I'm going to create another web application, another repository where I am maintaining my deployment code. Now, these are the terminologies. For now, you can skip because we are going to really do this particular piece. So we are going to say, okay, we have a Helm chart which we are going to use to deploy my application into the Kubernetes. So we are creating Kubernetes using Terraform. Okay, then we are saying using that ACR, same ACR using the pipeline. And for deployment, we are going to create another repository which is going to use Helm chart and going to deploy into my Kubernetes. Now, why we are keeping this one? Because we are going to use one more tool, and that tool name is Argo CD. Okay, which is a continuous delivery. This is only CI. We are going to use only for CI, and this is for CD. So continuous delivery is going to happen using Argo CD, and continuous integration is going to happen using your Azure pipeline. So far with me, guys? Any questions on this one?
So, Rohit, what is Terraform actually? Why we use it?
Yes, exactly. So now we are going into the Terraform. Perfect question at the right time. Let's jump in. Okay. So when we are talking about Terraform, what is Terraform, right? Why we are really using Terraform, and what is the advantage of using Terraform? Let's jump into that particular section. Okay. So now when we talk about Terraform, right? As we see that we have few options to deploy or provision any kind of a infrastructure. What are those options? We have Azure CLI and Azure Portal. Portal is definitely the manual way. 99% of companies do not use Portal. They only use for creating the first initial things, right? Maybe subscription. Sometimes they are not even using for subscription, they are just using subscription, and there are a lot of CMP, cloud management platforms, actually, which are available, or some automation which they can use to create the subscription. And once that subscription is getting created, they are automatically creating the complete skeleton. Now, what is the skeleton? Skeleton means roles, your AD, your AD configuration, maybe your virtual networks, all that skeleton, right? It is automatically getting created using one Terraform script. That's it. So in that one Terraform script, you can just put up one, your subscription details and everything, and you can run that Terraform script. What that Terraform will do, it will, or maybe you can run Azure CLI. Okay, what that Azure CLI will do, it will go, it will connect to that Azure, and then it will run one by one code. Okay, the way we have written in Azure CLI also, it will run one by one code, and then it will perform everything whatever I want to create in that subscription as a first step, like virtual network, hub and spoke network, and multiple things. Whatever we are really going to do, there are multiple things which we got to automatically get created. Perfect. So that is the first thing. Now, yesterday, I think you might have seen or missed. I will just quickly show you the code which we have run yesterday. So this is the code which I have run. I've created one pipeline, okay, and in that pipeline, we are just going to run one single job or task, right? We have this state, we have this job, and inside this state, we are inside this step, we have one task. Actually, I think I already showed you this in Friday, but I'm just going to repeat that. Here we are going to run the Azure CLI using the service connection which we have already configured, okay, and we are going to run a inline script. Inline script means whatever commands I am giving, one by one commands, it is going and executing that command one by one. So what is that one by one command? As your account show, which is not required, I'm just putting it in just to ensure that we are getting the thing. Here it is starting. Here it is starting with Azure ACR create resource group name. Now here this resource group name, we are taking it from the variable group, right, which we have created inside our Azure pipeline. Okay. In this, I have already mentioned the RG name. I have already mentioned the username name here. I'm providing SKU, which is standard. I'm enabling the admin here. Once I enable this one, I'm using the bash tag here, which is automatically creating a dynamic variable by using this particular thing. And I think I already showed you how we are getting this particular value, right? So this value we are getting, and we are executing this as a Azure. We are taking that as an Azure ACR username. Then we are taking that as a password. This is a dynamic one, right? We are not storing anywhere. We are just at the time of execution, we are using this and creating these variables, and then we are passing these variable values, okay, into the second line whenever we are really creating. But before that, we are going to create a plan. We are going to create a web application, okay, web app, and then we are kind of like creating a slot for that web app, which is a dev, and then we are then configuring or adding the app configuration. We are setting that up configuration by providing this kind of information. So first I'm saying, hey, look, this is the Docker container image I want to really deploy. And second thing is, when I'm going to configure this one, I'm saying, look, this is my Docker URL, and URL I'm taking automatically from here. Why? Because ACR username and ACR name is always the same. Okay, ACR name and ACR username is always the same. That's why we are just using as a one variable here, and I'm putting up that dot ACR Azure CR, right? This is, as we already know, that it is the by default it will automatically get added. So I'm just automatically adding the Azure CR.io app latest, and then we are updating the URL, we are updating the username. Okay, from where we got this username? We got it from this particular uh, command, or when we are really running this particular username is a value or variable. Where is the value? The value is coming from this code, this particular command. So when this command is executing, there is an output which is coming on as a value, and that value is getting assigned to my username, and that value I'm putting up here in my configuration. Same thing with my Azure password. So this is how you can really run hundred of line. You don't have to really run like one by one line. You can just write hundred of line. Everything you can create using this as your CLI. Everything is possible. Everything. Some of the things are only work with Azure CLI. Some of the things, there are some services actually which only works with Azure CLI. You cannot use portal for that. It's all API based. That's why you have to use the Azure CLI. Okay, so Azure CLI is having everything. That there is no problem with that one. So if we have already Azure CLI, then why we have to use the other options, or maybe some other things? Because when you are executing this Azure CLI, it will go, it first of all very slow, and it's a very traditional way of executing things. It's not bad. Again, for some things you definitely need to use the Azure CLI, but the kind of like execution time for this Azure CLI is very very slow. Why? Because what happens whenever you run this command, like first time you are running this command, which is okay. Second time when you are going to run this command, it will go, it will validate that whether the ACR is already available in my environment or not. If it is yes, then it will kind of like validate all the information, and then it will say yes, it's already created, and it is not going to give me any kind of a response saying that whether it was already created or I created this particular piece. Getting my point? That's a difference. Because here I am not getting any record saying that whether I've created this particular thing as a first instance, because I'm going to run this pipeline multiple times, right? Every time I'm going to add one new line here, it is going to execute. It's a continuous process. Now when you have a continuous process, you don't want to get stuck to a process which is very slow. And second thing is, it's a very repetitive, like same thing it is going again and again, and then it is getting stuck because of that one particular piece. What my expectation is that if I already created this one, then it should not try to attempt creating this one again one more time. Okay, so that's the main purpose what I'm really doing, and that is where Terraform really comes into the picture. As we will go and we'll see that. Okay, perfect. Now I'm jumping back to the Terraform. Okay, so now we have three options when we are executing without, or when we are trying to provision a resource without our portal. What are those options? We have Azure CLI, we have ARM templates, and we have Terraform. Now, Azure CLI we have already seen. Azure template or ARM template, I'm actually missing, or I'm kind of like skipping that particular piece in our environment. But I'll give you a quick environment. Now, why I'm skipping that, I'll also let you know that. Okay, so then let's talk about the pros and cons about each of the steps, right? Why we are really choosing Azure CLI and why we are going for Terraform and everything. Let's go about that one. So Azure CLI, definitely it's a native integration, script and automation. It is definitely used for scripting or automation because it's a command line. And when you talk about command line, you can use commands like bash or PowerShell to make it in a script way, and you can execute like one by one things, which is okay, which is good. Learning curve is very slow, very very kind of like fast. So you don't have to learn specifically. It's a very predefined and pre-configured, because a learning CLI is actually not a big deal, because you just have to understand the command and sideline test syntax, like we have seen, right? When I'm trying to create, first of all, every Azure command should run with AZ, then the service name like ACR, web app, your resource group, RG, whatever you want to really create, VM, all that thing, the service will be there, maybe the sub service in case if you have, and then the action: create, delete, update, set, show, all those things. Now once you have that configuration, you need to provide the variables. Okay, parameters, generally we generally call them as a parameters. Now what is parameter? parameter is nothing but any, whenever you really go with that one, any, whenever you really go with any kind of a, a script, that script always requires some input, and those inputs are nothing but the parameters. Okay, because by default as your CLI or any command line interface, whatever you really run, that command line interface, if you want to execute one particular command, you need to provide the input for that, otherwise it will not run. Okay, as simple as that. So that parameters are very very important, providing the parameters, and then you can use the parameter value from some variables. That's how it kind of like delivered. Okay, to make it more automation. Perfect. Learning curve is very simple. Okay, compared to ARM template and Terraform I'm talking about. Now when we talk about the ARM template, now this is the actual infrastructure as a code. Okay, IaC is very important, and infrastructure as a code is IRM templates is a true infrastructure as a code. I'm actually talking about. It's a native integration. It's a Azure provided one, so you can really run that in Azure environment, and definitely it's Azure specific, as I mentioned, right? uh, so that's the one thing. Second thing is infrastructure, the Terraform. When we talk about Terraform is also a very popular, and most of the companies actually uses infrastructure Terraform as a, for infrastructure as a code. The most important aspect about Terraform is that it supports multi-cloud. Multi-cloud means once you learn Terraform, you can actually apply this experience or learning to other cloud providers. You can use Azure, you can use AWS, you can use it on GCP, you can use it on Oracle Cloud, you can use it on premises setup, you can use it for OpenShift, you can use it for Vault, you can use it for Kubernetes, everything. So all this popular whatever services we have like multi-cloud, Terraform really works with that multi-cloud environment. Okay, that's where it's very very popular. Second thing is the state management, and we'll talk about what is the state management. But this is also one of the beautiful uh, process. That's why Terraform is very very fast, and that is actually missing in these two things: ARM template and Azure CLI. So state management is really missing, and that is also a very important, or a kind, I can say the winner in this particular thing. If I talk about is Terraform. Now, when we talk about ARM template and Terraform, why we are not really learning ARM template? You might be thinking that, why we haven't really touched about Terraform, because the cons. When we talk about cons, right, you have two things here. First of all, let's talk about Azure CLI. The Azure CLI is vendor locked in, okay, because it can only run using the Azure only. There is no other option you can run it for other cloud providers like AWS. AWS has its own Azure CLI, AWS CLI. Google has its own Google CLI, and everybody has its own Azure CLI. Like Kubernetes has its own Kubernetes CLI. Helm has its own Helm CLI. So all those CLIs are really Docker, as we have seen, right? Docker is having its own CLI. So all those CLIs are really separate thing. You cannot really run Docker onto Kubernetes, Kubernetes onto the Docker CLI. Don't work like that. AWS to Azure don't work. So that's the main problem. And then there is a limited abstractions. You cannot really use lot of custom codes and abstractions and all those things. That's not possible with the Azure CLI. It's a straightforward, just one single command. But yes, using PowerShell or using some scripting, you can actually convert that into something like a more driven, like one by one step. So it's not like, and you can also parameterize, because that is also very important. So you can use some variables, and you can use that variable into multiple sections, so which can make it more robust. Rather than putting up parameters every time, you can use as a PowerShell, you can use variables and values, and you can then use that values in another thing, like the way we have done in our pipeline. Then what is the difference when we talk about ARM template? ARM template, as we know, that is definitely do not have a multi-cloud support. However, it is having a learning curve. Okay, you need to spend time to understand how this really works out, and this provides in YAML as well as in JSON, both the formatting. But the format is completely different. Okay, format is again completely different when we talk about that one, because when you are trying to execute, as I mentioned, right, YAML is a standard language, but it has a different way of execution. For Ansible it will be different, for Terraform it will be different, for Kubernetes it will be different. That means if you know YAML for say like Azure pipeline, that doesn't mean that you know the YAML for Kubernetes. No, definitely not. It is not like, you know the Terraform Terraform code, and you understood that okay, Terraform code is written in this one, that means you will be automatically understand Ansible. No, that's not going to happen. Even though they understand JSON and YAML, but the formatting is completely different, the way they work is completely different, and how you write that particular code is completely different. So you need to learn that one. So it's a learning curve. Okay, so we have a learning curve for ARM template, and that's why when we talk about Terraform, it also has a learning curve. It's not like, it's very simple and you really go with. But when you have two things in hand and you have a limited time to really learn and go, I want you to focus on that thing which will make you very useful and which is actually getting used by many companies, rather than I don't know which companies are really using ARM template. Maybe there might be some companies we are using ARM template, but ideally ARM template, as I worked with very companies, nobody uses ARM template. Everybody uses Terraform. Why? Because they wanted to have that robust implementation, and they already want to prepare for the multi-cloud strategy, because not now, but people are already started working on a multi-cloud. They wanted to already start work on infrastructure which is kind of like going in anywhere. That's why Kubernetes is coming to the picture, that's why Terraform is coming to the picture, that's why Git actions and GitLab and all those things come into the picture. Why? Because they don't want to get stuck to one cloud, they want to really go explore multiple multi-cloud options. And Azure DevOps is also one of that, which is not stick to Azure. It can really be extended to multi-cloud setup. That's why we are learning Azure DevOps also, right? Because Azure DevOps has that power which can integrate with any cloud provider. Doesn't matter it is Azure or not. So it can really get integrated. So we are going to learn all those cloud agnostic services which are not cloud bounded and can be definitely used, because nobody in your interview will ask you about ARM template, but 100% in your interview they will ask you about Terraform. So it's a time that you want to invest, and I want you to invest your more time on the Terraform. Okay, perfect. And then definitely when we talk about some cons about these things, as we know, it is a learning curve. It is a kind of like a big learning curve with ARM template, no cloud support. Wherein when we talk about Terraform, yes, there is a learning curve. Less native integration, like it is not natively integrated with everything, but yes, it can do like pretty much everything whatever is possible using Azure CLI. Why? I'll explain you that. It has a slower adoption to new services. Now again, now because when we talk about slower adoption, sometimes what happens, say like in case if there is a new service which is published by Azure, so Azure CLI will be automatically available for that one, because without that thing they will ensure that whenever they are launching a new service, that is compatible with Azure CLI. But sometimes Terraform might not be that fast to implement that thing in their code. So that is the one problem. But generally Terraform is also very active, and nowadays because they work together, like Terraform company HashiCorp and Microsoft and Google and AWS, they all work together now. So because they know that nowadays Terraform is becoming so popular, so every company wants to ensure that whenever they are creating infrastructure, they are already aligned with Terraform, so Terraform can automatically update their code also. The moment I am having everything available, they will be also having their code updated. So they work very very kind of a close, and ensure that whenever the services are available, they are also get updated in Terraform. So that's the main thing. Now let's try to understand the Terraform definition. As we discussed already, it's open source infrastructure as a code tool. Open source means it's freely available, you don't have to do anything. It's a very small tiny kind of like a command line. Again, you don't have to install a big application, or you don't have to have a big server actually for that one. No, it's a very tiny small application CLI. You can run it anywhere. It allows you to define and provision infrastructure in a declarative configuration language. We'll talk about that one. It supports version control, resource graph, and execution plans to efficiently and predictable infrastructure management. Okay, we'll talk about this as we move on. What is the advantages? It works with multi-cloud. It has a scalability option. It can really scale up and down based on whatever information. It has a state management, which is very important. Okay, use cases, you can automated provisioning, you can quickly deploy and manage infrastructure, you can facilitate team collaboration and version control, and consistency. Definitely, that's the main thing across. Okay, now let's talk about the example, like how we are going to really do it. So in case if I have a Azure, inside that Azure I'm going to create a resource group. Inside that resource group I want to create something like a storage account, VM, and maybe a web application. For that I'm going to use the infrastructure as a code, okay, which is having a desired state management, and then it is very useful in quick deployment and definitely can make a copy of your infrastructure very efficiently. When I talk about copy, what is that copy thing? Say like if I have created one infrastructure as a code, and I have written that, okay, while creating the Terraform, create one resource group, and under that resource group create storage account, virtual machine, and web application. I've just written this particular three kind of like a code, right? Now I executed that using a Terraform. Now when I'm executing, it will ask me where I want to execute that one. I can say, okay, execute this in particular subscription. It will go ahead and create that resource group, and under that resource group it will create all three resources. Perfect, very good. But I can control that, saying that, hey, look, when you are creating a resource group, create a resource group with the name rg-dev, and I can execute, because I have just one value file or maybe an input file which I can really give as an answer file. And when I'm executing my Terraform, I'm saying, hey, look, go ahead and create an instance, okay, and values take it from this particular value file. And in that value file, I'm saying, hey, rg name is equal to rg-dev. My storage account name is sa-dev. My VM is sa-dev. My web application is again web app-dev. Simple, right? It is already creating. Now tomorrow I came back and I got a request saying that, okay, now you have to create exact same environment into the QA environment. What I'm going to do, I'm going to just change that value file, or I'm going to create a new value file saying that now the value file is, okay, qa dot select tst. I'm just giving an example, qa dot var file, for example. Now when I'm running the Terraform, then I'm saying go ahead and use this var file. Code is same, only answer file is changed because variable is changed. Okay, only variable change. The moment I execute, it will going and creating a new resource group which will have a name as rg-qa, sa-qa, vm-qa, web app-qa. Everything is created. Then I got a request saying that exactly same thing you need to create in a production. I can again go and do that. Exactly same thing, create a new answer file and run it, and then it will create. So that means using single code of my infrastructure, just by changing the value by file, I can create three different environments, and that is the beauty, which says you can quickly copy the environment infrastructure, right? Whatever the infrastructure you are creating, you can quickly do that. That's the beauty. Okay, how it works, let's try to see what happens. Whenever you have this AWS, Azure, or GCP, they all have Azure CLIs. There's their own CLIs, right, as we have discussed already. uh, and then what Terraform will really do is that it will connect to all this Azure CLIs or download those CLIs. It has its own compact version of CLIs which is already created from these things, and Terraform create a wrapper on top of that. Okay, so Terraform AXE file will create a wrapper which underline use this Azure CLI only, underline use AWS CLI only, underline use GCP only. However, okay, however, there is a wrapper where you will not understand that what exactly it's happening inside. That's the main difference. Now, when we talk about this difference, how this Terraform understand that, okay, I want to run this particular code onto Azure, or I want to run this particular code onto AWS or onto GCP. So for that, we need to provide something like a configuration. And in that configuration, we need to provide the first thing as a provider. Now, in case if my provider is Azure, I need to mention provider as Azure. If my provider is AWS, I need to mention provider as AWS. If my provider is GCP, I need to provide that as a provider as a GCP. So the moment I make that provider details, again, that's a code, a small piece of code. Once I put up that small piece of code, it understands that I want to run this on a Azure, and it will automatically download the Azure CLI and the compact version, which is again maintained by HashiCorp. They have maintained and they have created this everything in Go language. Go language is very, very popular and very powerful, which is used for Terraform. Kubernetes is completely built up in a Go language. So they use this Go language, and then using that Go language, actually, they are kind of like doing all this execution, which is very fast. Okay. Now, once you create a provider, once you specify the provider saying that, okay, I want to run Azure like I want to run, I want to connect to Azure like. Now it will ask me what kind of resources you want to create. Give me the list of resources which you want to really create in this Azure. So I need to then provide the resource lists, and I can create hundreds of resources. Everything in a cloud, when we are creating Azure resource, right? Everything is a resource. Virtual machine is a resource group itself is a resource, virtual machine is a resource, storage account is a resource, ACR is a resource, your web application is a resource, your database is a resource, whatever you call it as, right? Everything is a resource in a Azure environment or in any cloud environment. Everything they call it as a resource. Okay. We are also resource, like we are human resource. For a company, we are human resource. Then there will be some business resources, then there are some technology resources. So different processes which we have here, right? These are all technology resources which I'm talking about. Now, okay, once we have a resource, what kind of action I want to really do with this resource? Okay, should do you want me to create this, update this, or delete this? Everything I can really do, because we have to specify these things. So these are the three major components of providing or creating a provisioning a resource or an infrastructure in a cloud environment. And these three things are a kind of like a subset of your complete Terraform: what provider, what resources, and what action. Let's see that. When we talk about Terraform breakdown, right, let's see about provider, how that provider definition is really doing. Now, as I mentioned, right, Terraform is all about script, it's all about code, it's all about the things, blocks. But you don't have to remember everything. By the time you get into this particular environment, you will get habitual for these things. It will be very easy, to understand and stuff. So in case if I want to write a provider here, this is a block of code which I need to really put up. And the good part is, okay, once you go through this one, you will repeat this one multiple times, so you will automatically get habitual that, okay, this is how you will be writing this one. Okay. And you need to learn this one. It's very important, because if you make a small change here, this particular code will not run. As simple as that. The second thing is, this is a script. If you see this script, particular script, it is not completely JSON, not completely YAML, or not completely a normal thing. It's something different, right? If you see, it is using the curly braces, which is generally get used in JSON. It uses equal signs, which generally get used in your text file, and it is also using some indentations or something like that, which is generally get used in your YAML file. So it's a combination of three things. But this is actually very simple. If you ask me, this is quite simple. Why? Because it's giving me a human readable options, and I can really provide whatever I want inside that one. So it's a combination of three things, and this combination is created by HashiCorp itself. HashiCorp is a company, okay, which is created this Terraform. So all these tools, right, whatever you use, HashiCorp, Terraform, your Vault, all these tools, whatever you are seeing right now, they are all created by this HashiCorp, which is really, really getting popular, very, very popular. Okay, Terraform is created by that, and there is a this particular style of a formatting is actually called as HCL. It's HashiCorp configuration language. Okay, so HashiCorp configuration language is used to define this one, which is, if you have a kind of like understanding, and I'm by far you will really get habitual for this one also, how they are really writing it. It's very, very simple again. So in this one, if you see, yes, you have a Terraform here. Under that Terraform, everything really gets into the curly braces. You have a required providers. You can multiple provide multiple providers here, but here I'm going to provide the Azure RM. Now, as a source, as you see that whenever we are going for Docker, by default, where Docker goes? By default, Docker goes to whenever I'm pulling any image, it goes to Docker Hub. Similarly, whenever I'm just mentioning the source here, it is going to HashiCorp. HashiCorp is a company. Slide Azure RM. It's already there and it's already there, and version is also mentioned that okay, I want to use this source Azure RM provider with this particular source, and then version is this one. Now this source will download the Azure CLI. This is the method which you will be specifying in your code, and it will help you to download that particular piece. Okay, this is a provider block. How about the resources? And you are going to save this as a provider.pf file. Now, whenever you are going to run a Terraform, you have to ensure that that Terraform file gets ended with .tf. You can create hundreds of files, and when you run an in a folder, say like in case if you created 100 tf files, okay, and when you run Terraform within from that particular folder, all the files whichever is there in the .tf file, they will get consolidated as one file, and Terraform will run that as one single file rather than running that as 100 files. So you can have all the references, different files, different things in a different files, and even folders also you can really create. Now why that is important? Because in a production environment, it actually happens that you are end up creating hundreds of resources, and you don't want to create all those 100 resources in one single file, even though Terraform is considering that as a one single file, but you don't want to create that. Why? Because of the manageability of the code. So that's why what we generally do is we go ahead and create a file which will be for, say like, virtual machine. I'm going to create a vm.tf file. I want to create a source a server. I want to create a resource group name. I'm going to create a rg.tf file. I want to create a storage account. I'm going to create sa.tf file. Why? Because tomorrow, in case if I want to only go and change some values in my storage account, I should be able to do that quickly by just looking at that particular file. I don't have to scroll down all my code or find out the code. That will be very cumbersome. So I will really, this is a kind of like a standardizing and making it more beautiful in terms of folder structure. How you really put up that one. Because when you are writing a code, it is very important how you structure your code. That's why if you have seen any application also, you might be seeing like there are a lot of files inside that one, but every file will have only maybe 200 300 line of code, and maybe they immediately go into a different file and then they create a different code. Why? Just to manageability of that code. I don't want to create one file which is having like 1 million lines. No, definitely that time is gone. Earlier it used to happen. Now nobody really uses that. That's not a standard, or that's not a best practice. Best practice is kind of convert your code into smaller block, smaller files, and make sure that they are really very manageable. Okay, as I said, same thing which happens with the resources. When I'm trying to create a resource here, this is the code actually which I really start with. I'll start with something like a resource, and just go with this one. You don't have to remember anything. Don't get into understanding all those things as the first thing. As we move on, definitely you will see how things are really shaping up. Resources were there, Azure RM container registry. Now everything, whenever I want to create any resource, what Terraform really understand is that, because as a Azure CLI, right? When you are running a Azure CLI, can we use AZ space ACR instead of ACR Azure container registry? Can we do that? No, we cannot do that, because when you're running a Azure CLI, you have to make sure, or any command line interface, you have to make sure that you have to adhere with the exact syntax which is really given. You cannot run any syntax. Okay, for example, in case if you want to run a dir command, you have to run dir only. That's it. There is no other alternative. If you want to provide a folder name after that dir, that will be your parameter. Yes, you can do that, but you cannot say dir instead of dir I want to run something and I want to get that one. No, that's not going to happen. Exactly same thing. When you are running a Terraform expect that you run that in a, or maybe you write that particular code in a specific block. Now the good part is this code is already available. I'm giving you enough information, enough code with you, so you can just copy paste that code. But I don't want you to copy paste as like blindly. Understand what is really happening here. Okay. So first thing is resource. We have to start with resource. Everything is a resource, as I mentioned. Start with resource, give a space, and in double code, provide the resource type. What kind of resource you want to create? I want to create a container registry, but that container registry I want to create in Azure RM. So this is a standard because it's a multi-cloud support. What it says that okay, you can go with multi-cloud with only Azure container registry. If you want to create AWS container registry, you need to mention AWS container registry. You want to create GCP, you want to say GCP underscore artifact underscore registry, whatever they call it as artifact. They don't call it as a container registry. Okay. So here you want to create a Azure virtual machine. So you will say Azure underscore virtual or compute maybe virtual machine. In AWS, you will have AWS underscore EC2 instance. In GCP, you will have GCP underscore virtual machine. So that is how you can just mention the resource. So Terraform will understand that, oh, okay, by the way, I want to create this resource here. Second, this ACR is a temporary name. What happens? We want to use a references like variable, and I can use the variable of one resource to another resource. So say like when I'm creating this resource group or maybe ACR, I want to update this ACR details into some other resources. So that reference, I can use that reference point as my ACR thing. We will see that as we move on, right? Then pretty standard parameters, and these are really important. You want name, and then you have to put up everything in a curly braces. That will say that my resource creation is starting here, details, and ending here. And then I can create another resource below this one. I can create another resource below that one. In a one single file, that is fine. I can really do that. Or I can build it then a separate file. We'll see that. Resources, Azure Container Registry, ACR, name, name of the resource group name. This is again exactly same thing you have to provide. You cannot change it like RG underscore name or something like that. No, you have to provide that in the exact same name. Okay, resource underscore group underscore name. Perfect. Location, Central India. Here you have to give the actual name which you are seeing in the portal. You don't have to give a Central India because in Azure CLI, that's the difference. In Azure CLI, you need to give everything in a small letter. Central, and should not be any space. So Central India. So Central like CENTRALINDIA. So you have to put up something like this. Or West US. In case if you have a West US, you will say WEST US. That's it in a small letter. In a Azure CLI I'm talking about. But in a in Terraform they made it like kind of simple for us. So you can use this method like Central C capital I capital space. It's all okay, and it's just how you have to really put up. If you put up a Central India without no space and in small letter, it will not understand. It will say, hey, there is a problem, I don't find this location. So you have to provide this in the same format only. SKU, standard, you have to put up that in a standard, and then you can really run that. S should be capital here. I think I have just copied pasted, that's why S should be capital, but in my code it's all fixed. So you just have to mention that one. Now this is, you can create something like a vm.tf, sa.tf, eb app, whatever you have, a app.tf, you can really create it based on whatever the tf you can really do it. Actions, what actions? Now you can see the provider. I give you three things, right? One is provider, another one is resources, and then there is action. Three blocks. Action is init, which is initializing and ensuring that whatever the providers you are provided, it will automatically download the CLIs and packages and everything to ensure that it is able to execute that particular thing. Second, it is going to plan. This is very interesting. Even before creating your resources in a cloud, Terraform has a flexibility that it will show you exact details based on whatever you are going to provide him the code. It is going to say, hey, okay, I'm going to create this particular resource. I'm going to change this particular resource. I'm going to destroy this particular resource. Destroy means delete. In a Terraform word, it's destroy. I'm going to destroy this one. I'm going to create this. I'm going to update this, or I'm going to destroy this. It will give you that particular plan before even executing anything. Then your actual apply. So plan is just a planning. It is giving you, okay, I'm going to create this resource group. I'm going to create this one. Is it okay for you? Does it look good? Is there any changes you want to do? No, I'm good with that one. Perfect, fine. Everything is looking good. Then Terraform apply. This is where the actual application will do. So whatever you have written, code and everything, you will apply that, and you will ensure that that is getting created in your Azure environment. And finally, you can do the destroy. So once you're done with this, so use case could be you are you want to create one resource, or maybe we want to test one application. Now that application can really work on a Kubernetes environment. Perfect. What you are going to do? You are going to create one Terraform file. Okay, you are going to say, okay, and then you want to quickly deploy that. Maybe you want to run it for 1 hour, and then you want to destroy it. Perfect. You create an environment, you put up all the resources, you put up the provider, you run the command Terraform apply. It will apply everything, it will create all the resources. You will test the resources in maybe next 1 hour. You will inform your testing team saying that, okay, this is the Kubernetes cluster which is up and running, this is the application which is deployed onto that one. Go ahead and test it. You have next two seconds, and your pipeline, you can again trigger your or schedule your pipeline. Say like after 2 hours, go ahead and destroy this particular thing. You can do that. And then what will happen? After immediately 2 hours, my pipeline will again get triggered, and then after 2 hours, it will go ahead and destroy that particular thing. Or I can put up a slip in my pipeline itself, that okay, my pipeline once apply is done, slip for maybe 2 hours. Okay, don't do anything for next 2 hours or 1 hour. And after 1 hour, execute the next step, and that next step is destroy whatever I've created. I can do that. In same pipeline, I can do that. So I can do the init, plan, apply, and destroy in same file by giving the timelines. But plan and apply should be fast. It should be immediately, because apply and destroy, there should be a gap between apply and destroy. If you want, again, if you want, you can really keep it separate, or if you can keep it completely, you can remove that destroy piece completely from this particular thing. It's up to you, but it is giving you that flexibility. Perfect, guys. Any questions so far? I think we had a long discussion, but anything you want to see? Because I'll just give you one sample thing, and then we will close for day, and tomorrow we'll get into more details, see the action things live, how you can really run the Terraform everything. Okay, so breakdown of CLI is that if you run this Azure CLI, right, this is how we are going to create this, and how Terraform is really putting up that one. When you are running the create a resource group, right, this is the command which we are going to run for creating a resource group. Az group create resource group name hyphen location central India. Exactly same thing I want to convert into the Terraform code. Resource, I will start with resource. I will start with AzureRM resource group rg underscore name. This is a temporary name which I'm going to use. Name, again, here it was having a resource group name. Here I'm just using a name equal to whatever the rg name I'm using. Location, hyphen location. Instead of hyphen location, I'm just putting just a location. Here hyphen resource group, I'm just putting up a name. Now here also it's name. Actually, you can really go and put up a name here, and then we can really go with location central India. Here it is all small. Here you can have a choice. Okay, here if you want to create a ACR, second option. For ACR, what is something which you can really go? AZ ACR create resource group hyphen resource group rg name hyphen name of the ACR ACR dev hyphen SKU standard hyphen admin enabled true. Okay, let's see. Azure resources, AzureRM. AzureRM is here also. AzureRM is here also. Container underscore registry. Giving a temporary name, ACR. Again, a name. Now here name was different. Here name was definitely different. ACR hyphen dev. Resource group name, RG new. Location, Central India. SKU, standard. I've actually skipped admin here, but you can also mention admin underscore enabled, and you can mention equal to true. Simple. So this is how it is breaking down. It's again a very simple thing, um, but yes, definitely it's a learning curve. But yeah, that is something which we really have. Now, final topic is the state management. How this Terraform is really maintaining all these things and why we are really using Terraform. Because of the state management, what really happens whenever Terraform get executed, you will be having three components. You will be having a configuration file. Terraform is just a sample simple AXE file or a CLI command line interface. So it won't really keep anything with it because you are running that in a pipeline. It's like a CLI. CLI doesn't keep anything here. So what Terraform will really do? You will have a configuration files which are nothing but your TF files. It will take out those TF files and it will send it or it will execute that on your Azure. Now, when it execute that on Azure, it will get the return saying that yes, I've executed and my resources got created in Azure. The moment the resource got created in Azure, Terraform will actually save there in a some file-based database. File-based database. This file-based database is a state file which is kind of like having everything in a JSON. I will show you how this state file really look like. So this will run as a state file. Everything you can see that as a state file, and that state file will be a file based database. But the challenge is, if you continue or if you store this in a pipeline, this state file will get immediately deleted because that instance is automatically getting deleted, right? When you run a pipeline, that instance is not constant. It that instance is getting created when you want to create a run a Terraform, and then once you execute, that instance is going down. That means along with that instance, whatever the state, whatever you have, it will go deleted. So you don't want to store that state file because this state file become your single point of uh, details, because next time, in case if something goes wrong, okay, so first time, next time when your configuration will run, first time Terraform will go and read it from the state file, and then we'll compare that with Azure, and we'll find out that yes, that state, that no, that resource I've already created in a Azure, so it will not go and try to create that, which will cut down the overall execution time. Correct? Because Azure CLI is having this problem. Azure CLI every time goes, validates in the Azure and see that whether that is available or not. But Terraform will not do that because it is actually created for that CI/CD pipeline for the faster execution. So it will maintain that state. It will say, hey, okay, this configuration I think I already created. I don't have to go back to and create this one. I'll say, hey, everything is created. I don't have to do anything here. But in case if it find out that yes, this state is not available and this particular thing is already created here, okay, then it will say the execution is already, or maybe the resource is already executed, already exist. It will fail. But if this state is already here and the resource is not here, then it will recreate that resource here. That's the main thing. That's the beautiful advantage. But to maintain that one, what we need to really do is we need to also keep this state file safe and secure. So we can every time whenever I'm running a Terraform can execute or connect to the state file which is globally accessible and can then execute the commands. So for that, what we do, we actually store the state file in a storage account. Which storage account? Azure storage account. We create a container, and inside that container we store the state file. So every time whenever Terraform will execute, it will download this file, okay, or it will connect to this file. It will modify everything whatever you have. It will lock that file for that particular time, and then once that particular implementation is done, it will update that particular file and it will then unlock that file. Now, why this locking and unlocking is progress? Because there might be a chances that there are multiple other developers are executing things. So the moment in case if I'm doing something and you want to really execute something, I don't want you to really use the same state file. Otherwise, you will be having a conflict. And to avoid that conflict, it automatically lock this file. And if my execution is already in progress, and if you try to do that, it will straight away say that okay, file is locked, I cannot read it, and it will, your pipeline will fail, not my pipeline. But once my pipeline is executed successfully, if you rerun your pipeline, then it will say yes, I am able to do it. Why? Because that lock is already released by my Terraform thing. We'll see this in action. But just keep in this mind, this is the particular thing which we are going to execute tomorrow. Perfect, guys. Anything else? Any questions on this one?
Yeah, Rohit, just come back to the next before screen, please.
This one?
No, no, before. We source. Yeah, here. See. Okay.
Mhm.
Um, Terraform. You mentioned that resource group name is AzureRM underscore container underscore registry is a uh, uh, default format, right? We can't change it.
Yes. No.
Okay, and resource group also same. Resource underscore group underscore name is also default. We can't change it.
Exactly. Yes.
Parameters.
Yes.
Okay.
Only
So
values you
ACR,
can change. Only values.
yeah,
Only
yeah,
values.
yes, yes. If it is ACR means Azure AWS means ECR, that we can give alternate name for registry, correct?
Which one? Which one? Sorry.
ACR is a registry repository name, right?
Here. This one, right? Here.
Yes, yes, yes.
No, no. This is a
Mm,
temporary name. Actual name is this one. This is a value. This is a temporary name. Now, why we are using the temporary name, I'll explain you. But that is not the ACR name here. This is a temporary name.
okay,
This
okay.
is the
So
actual name. This is the actual name of the resource which you going to try to, which you want to create in Azure.
okay, okay, clear. So Rohit, so far we have not discussed ARM template, right?
No.
Okay, 1 second, please. See, uh, once we create any virtual machine or web services, after creating virtual machine or web services, we will convert as a ARM template. Correct?
Mm-hmm. Okay.
So,
We can
in
convert that.
this,
We can convert that.
yeah, yeah, in that, after converting, it will be the code will be as a infrastructure as a code, right?
Yes.
Yeah, super. See, in this case, we can see the code, right? In template, we can how it is formatted.
Mm-hmm.
No, we can see the code, right? How we providers, how we give. It takes automatically. It takes automatically, right? From as per standard IaC standard. Provide information, resource information, and action information. Whatever we give GUI model, the code. I
Mm-hmm.
mean, this template will be having this AC the Terraform code, right? As we discussed now.
Mm-hmm. Mm-hmm.
Yeah, so if it is some like that means my request is tomorrow we do one thing. We create one template, ARM template. So we create manually a virtual mission or web services that we convert as a template, ARM template. We see the how this Terraform code actually. I mean, provider resource action plan.
No, 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 no. Again, that is not possible. Terraform, you cannot convert that from the template.
No, no, code we can see right at least how this resource code we I mean how providers information it took is
No,
automatically
that will be
resource information.
why you want to do that? I didn't understand that.
Actually, no, no, my doubt here. So, writing code explanation good now. The explanation code is good. So, if it is template is depend on infrastructure as a code, we can see the code how it is format. Then you explain the code. It will be easy to understand us. If it is possible, I'm just my imagine.
No, no, that will be more complicated. That's what I'm telling you. If I go into that particular thing, it will be more complicated. Then you will have to learn ARM template first. You getting my point?
Okay,
Why I'm giving you difference between Azure CLI and the Terraform directly? Because I don't want to give you that middle piece. Otherwise, you will get confused. Not you, but maybe
okay,
others also can get confused.
okay,
Okay,
okay, okay.
say like you have there are two things, right? Either you can learn I'm in a normal environment, right? Say like you can learn Java or you can learn .NET. I'm just giving a hypothetical example, right? Now you know that it will all both will require the time, energy, money, and everything, the time whatever you have. Now you know that which is more beneficial. Maybe Java is more beneficial. Why? Because it's more cloud native. A lot of companies really uses that one. .NET is also okay. I'm not saying that it's not good, but Java has its own beautiful flavor that a lot of companies uses. Which one you will learn? And again, I'm telling you, when you get into a detailed understanding, because going with just a ARM template, it will not help. Then you have to go to little deeper. I have to spend almost like 10-15 classes to explain you everything in the in the ARM template, and then again
No,
10-15 classes into the Terraform. Otherwise, you will get confused that why we are using a Terraform, why we are using ARM template, why we are creating, and again, when we are creating the Azure template, once I create anything, and once you create, it's really complicated. ARM template is really really complicated. It's like, why there are hundreds of things actually it will show me that okay, this is there, this is there, this is there. Then you will imagine that why we am actually using this one, why am I not really, I'm using this one. That's what I'm telling, right? If it is used by many companies, yes, I will definitely help you. But if it is not, because like for example Jenkins, right? Why we are not learning Jenkins? Jenkins is so powerful. There are also a lot of companies using Jenkins, but Jenkins is outdated. It's all gone. It's like no companies nowadays using Jenkins, or there are few companies who are using Jenkins. So I don't want to give you that few options. I want to give you option which is more valuable. And this, yes, everything required learning. There's nothing like, you can, that's what I'm saying, right? If you learn select Kubernetes, doesn't mean, or Terraform doesn't mean you will be automatically understand Ansible. No, not at all. Or if you are learning AWS or Azure, that means you are now can learn easily on AWS. No. Yes, there are few small
No, no,
things.
no, no, no. So my doubt is clear, very clear. Azure templates depends on is IaC, right? That's what we
No,
discussed.
no, 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 no. Yes, it's
Okay,
a part of IaC, not depend on IaC. It's a part of IaC. It's
okay,
one form
okay.
of IaC.
Then it's fine. I thought it was to
Yeah.
completely depend on IaC. If it is
No, no,
IaC,
no,
we
no, no.
just create. Okay,
No,
okay,
no. It
okay,
is not completely depend on IaC. It's a part of IaC, and it is not a fully IaC. I'll not call it as a full IaC.
okay. Then it's fine. No problem. No problem.
Yeah. Great,
Yeah,
guys.
yeah,
Thank you
yeah.
very much. And then we'll talk to you tomorrow. Bye.